Hi everyone. In this video, we're going to learn how to prove the identity using the three basic identity. The first identity that we are going to use is sine square plus cos square equals to 1. And you can derive the second identity, tangent square plus 1 equals to secant square, by dividing the first identity by cos square theta, at both sides. You will obtain the second identity. And using the first identity, divide both sides by the sine square theta, you will obtain the third identity, that is 1 plus cotangent square theta equals to cosecant square theta. Let's look at the first question that we are going to prove this identity. Tangent square theta minus sine square theta equals to sine power of 4 theta over cos square theta. So here I'm going to prove from the left side. We will define this as my left side, which later on we'll use a symbol LHS. And this is RHS, which is representing right hand side. Here I'm choosing to prove from the left hand side, that is proof from the tangent square theta minus sine square theta, because what I can see that I can simplify, which I convert the tangent square into the sine over cos, and then equating denominator, and later on simplify to the right hand side. So here tangent square, I will change it into the sine square theta over cos square theta minus sine square theta, copy down here. And now you look at the right hand side. Right hand side consists of only one term, so here I'm going to equating denominator to make it into one term. So I've got my I get my cos square theta. The numerator, I still have sine square theta. Here I'm taking this sine square theta multiplied by cos square theta. I have this. So here I can see that the sine square theta can be factored out. Factor out the sine square theta. I got my 1 minus cos square theta divided by cos square theta. Using the first identity, which you need to be very sensitive with the identity, the three identity that I show you just now. Sine square theta plus cos square theta is equals to 1, right? So 1 minus cos square theta, it can be written as a sine square theta. So I will substitute the 1 minus cos square theta as a sine square theta, and this is divided by the cos square theta. Sine square theta multiplied by sine square theta, that will be sine power of 4 theta over cos square theta. And looking back to our question, you are actually already proven to the right hand side. So we say that this is equals to the right hand side. Then we say that we have proven the statement. For the second example, I'm going to prove this identity. I'm going to start from the left hand side, which I represent with the LHS. The left hand side is 1 plus cos A plus 1 over 1 minus cos A. You can see that at the right hand side over here, there's only consists of one term, that is 2 cosecant square A. So at the left hand side, I got two terms, right? The only way that I can make it into one term, that will be equating denominator. Equating denominator, I'm going to take this first term, multiply by 1 minus cos A. So the denominator will become 1 plus cos A multiplied by 1 minus cos A. And the 1 need to be multiplied by 1 minus cos A as well, plus the second term, the numerator, need to be multiplied by 1 plus cos A. Then I simplified it. Simplify the numerator, I got 1 plus 1, that will be 2. Negative cos A plus cos A, that is 0. Divided by, expand this, you will have a 1 minus cos square A. Okay, so again, I'm using the first identity, which is the sine square A plus cos square A equals to 1. So 1 minus cos square A, it can be written as a sine square A. Replace the 1 minus cos square A as a sine square A. And this is equals to the 2 cosecant square. Alright, so you have proven this until it is equivalent to the right hand side, which is similar to the question. Okay, then we say that we have proven the statement. For this example, I'm going to prove from the right side to the left side, where this is the LHS, left hand side, and this side will be right hand side. So what I can see that right hand side contain of cotangent. So the cotangent I can convert into the 1 over tangent and then simplify. Hopefully it can be 1 over 1 plus tangent, same as the left hand side. So start from the right hand side, I got my cotangent theta over 1 plus cotangent theta. Cotangent theta converted into the 1 over tangent. I have this. Okay, then I'm trying to equate the denominator at this for this. Okay, that is a 1 over tangent. At the numerator, I just put it down here and divided by trying to equating denominator for the denominator here. That will be a tangent theta plus 1 divided by tangent theta. And here you see the sine divided by a rational expression. So I will try to make it multiplication, and you need to find the reciprocal of this, meaning that reverse this, you will have tangent theta over tangent theta plus 1. What can we see here? Tangent theta can be cancelled off. Finally, we have a 1 over 1 plus tangent theta. This is equals to your left hand side, and we say that we have proven the identity is true. Let's proceed to the next example. I have a secant power of 4 minus secant square equals to tangent power of 4 plus tangent square. I'm going to prove from the left to right, either left to right or right to left. Both sides are fine for this example. Here you must find an identity which can relate the secant and the tangent. So here I got one identity. I showed you before at the beginning of this video. There is only one identity that relate the tangent and the secant. That is 1 plus tangent square equals to secant square theta. Okay, so here later on we are going to use this to prove this identity. So for this question, you can either prove from the left side to right or right side to left. Both are fine. Okay, so here for this example, I'm proving from the left hand side, hoping to get to the tangent power of 4 plus tangent square. So looking at this secant power of 4 minus secant square, I factor out the secant square. In the bracket, I still have a secant square theta minus 1. So here you can see that the secant square can be replaced by 1 plus tangent square by using this identity. I'm substituting a secant square theta as a 1 plus tangent square theta. And the secant square theta minus 1 can be replaced by tangent square theta by using the same identity. And after that, we expand it. We have a tangent power of 2 plus tangent power of 4. This is equals to your right hand side. Then again, we say we have proven this statement is true. For this example, we got the secant square plus cosecant square, proving to the secant square multiplied by cosecant square. So here I'll start from the left hand side. I'm trying to convert the secant into the 1 over cos square alpha plus cosecant convert into the 1 over sine square. And then equating denominator, make it one term because at the right side we see that there is only one term. There is a multiplication of the secant square and the cosecant square. So here we are trying to make it into one term by equating denominator. I got cos square alpha multiplied by sine square alpha at the denominator, and the numerator I got the sine square alpha plus cos square alpha. Yeah, taking the 1 multiplied by sine square, you have this. Taking this 1 multiplied by cos square alpha, you have cos square alpha. And having the first identity, we know the first identity tell us that sine square alpha plus 1 plus cos square alpha equals to 1. So we have a 1 over cos square alpha sine square alpha. Now you can see that we have a 1 over cos square alpha can be written as a secant square alpha, and 1 over sine square alpha, it can be written as a cosecant square alpha. Then this is equals to your right hand side. Again, this is proven. For this example, here I look at the left hand side, there is more information compared to the right hand side. So again, I start from the left hand side. What I can see from the left hand side is containing the sine and cos, and the right hand side containing only the sine. So I decided to change all the cos in terms of sine. Here you have a sine square x, just copy down, and the cos square y, I will replace it by the 1 minus sine square y by using the first identity, and the cos square x here is going to be converted into 1 minus sine square x, also using the first identity, multiplied by the sine square y. And now we expand it. I've got my sine square x minus sine square x multiplied by sine square y, negative 1 multiplied by sine square y, you get negative sine square y, and negative multiplied by negative, you get positive. Positive sine square x multiplied by sine square y. Then finally, you will see that there is a term negative sine square x, sine square y. And here is a positive sine square x, sine square y. Both terms, when we combine them, it cancel each other. You get 0. And finally, there's only left 2 terms. That is sine square x minus sine square y, which is equals to your right hand side. And for this example, I'm going to prove from the right side again, because seems like the right hand side got more information compared to the cotangent theta. If you start from the cotangent theta, maybe you got no idea how to prove it into the right hand side. So we start from the right side. And what you can see at the left hand side, only cotangent, and cotangent always can be written as a cos over sine. So it give me the idea that the square root of the 1 minus cos square theta, it can be converted, it might be converted into the sine theta. So here I got the cos theta over square root of 1 minus cos square theta. It can be converted into the sine square theta by using the first identity. And square root of a sine square, I can write it into the form of sine theta only. So cos theta over sine theta is actually equals to cotangent theta, and this is equals to the left hand side. Then you say you have proven this statement. For this example, I'm going to prove from the left hand side. Left hand side containing 1 plus sine t multiplied by 1 minus sine t. So here I'm going to expand it first. I got 1, okay, 1 minus sine square t. 1 minus sine square t given by the first identity, it can be converted into the cos square t. And the cos square t, it can be written as 1 over secant square t, because they are the reciprocal of each other. So we say that this is equals to the right hand side. For this example, we need to prove from the left to right side. And you can see the left side, we have the double angle, that is 2 theta. And the right side, we have only a single angle, that is only theta. And now we can we need to use a double angle formula for the cosine, which is I have written here, cos 2a equals to cos square a minus sine square a. And also can be written as a 2 cos square a minus 1, or you can write it in the form of 1 minus 2 sine square a. So I'm going to expand this using this double angle formula. Okay, we start from the left hand side first. That is 1 minus cos 2 theta over 1 plus cos 2 theta. Then now I'm going to change the cos 2 theta using the maybe you can use the second formula, that is a 2 or using the third formula, because I hope that I can get a sine over cos. Sine over cos is equals to the tangent, yeah? So on top, I use the the third formula, which is 1 minus 2 sine squared theta from the cos 2 theta converted into the 1 minus 2 sine squared theta using the third formula. And down here, the cos 2 theta, I will use the second formula. Okay, second formula, that is 2 cos square theta minus 1. While I use the sine on top and down here I use the cos formula. I mean this third formula I'm using as a at the numerator, and the denominator I'm using the second formula because I hope to get the pattern in the form of a sine over cos, because the tangent square is consists of sine square over cos square. So here I simplified it. I got my 2 sine square theta, and down here I have a 2 cos square theta. Where the 2 cancel off, you get the sine square over cos square. That is equals to the tangent square theta, which is equals to the right hand side. Of course, you can, if you can't see initially, you can always use either formula that you like, but maybe the procedure or the steps will be a little bit longer. Just like that. Okay, if you use the first first formula of the cos 2a, later on you might need to change the either cos into the sine or sine into the cos by using the first identity, just like that. For this example, I'm going to deal with the compound angle formula for the sine and cos. These two are the formula for the compound angle formula for the sine and cos. Here, I'm trying not to use a calculator to calculate the left hand side so that it is equals to the set 3 over 3. Start from the left hand side. Start from the left hand side. I got my sine 75. Sine 75 is not our special angle. In order not to use a calculator, we have to relate to the special angle. The special angle including 30, 45, and 60 degree. So here we try to relate the 75 with the 30, 45, and 60. Okay, 75 consists of 30 plus 45. And sine 15, we can relate to 60 or 45 minus 30. That will be 15. And this is divided by cos 45. Again, the cos 75 replaced by 30 plus 45. And cos 15 here will be 45 minus 30. Okay, so you can see that those are actually using as a compound angles to relate to the special angle. Okay, so for the sine 30 plus 45, I'm going to use the first compound angle formula, which this will be sine 30 cos 45, which is A is your 30 and B is a 45. So we have a sine 30 cos 45 plus follow back this sign over here plus cos 30 and sine 45. Okay, this is how we expand for the first compound angle. And for the second compound angle, which is sine 45 minus 30, using the first formula, same formula, but the sign now become negative. Become negative. I have a sine 45, okay, and cos 30 minus cos 45 sine 30. Okay, and this is divided by, expand this by using the second formula, which this is when this is a positive plus, right? The formula, when you expand it, it will be negative here. So you have a cos A minus B, okay, cos A plus B equals to cos A cos B minus sin A sin B. Now as if that your A is 30 and the B is 45. After I expand, I got this positive. Expand the last term, which is a cos 45 minus 30, using the same formula. Okay, so here I got my A as 45 and the B as 30. Yeah? A as 45, B as 30, and the sign is negative. When we expand, here will be positive. So we have a cos A cos B plus sin A sin B. Okay, sin 30 cos 45 plus is that sin 30 cos 45 is here, not this term, and this term, they are the same. So I will just combine them. I have a 2 of sin 30 and cos 45. And this term, and okay, let's look at this. This term and this term, they are the similar term. So I combine them. Okay, got 0. We got it 0. Yeah, positive, negative, we got it 0. And down here, let's try to look for the like term, which is a cos 30, cos 45. Yeah, these two terms, oh, sorry. These two terms, they are equal. Okay, cos 30, cos 45. So we got a positive plus positive. Positive. We have a 2 of the cos 30, cos 45. Okay, and the negative sin 30, sin 45, they are similar term. We have this is the similar term, like terms. Okay, one is negative, the other one is positive, so we just cancel off each other. So finally we have this. Now we can simplify. To substitute value, sin 30, that is 1 over 2. Cos 45 is 2 over 2 divided by 2 of the cos 30, that will be 3 over 2, and the cos 45 again is 2 over 2. And here you can cancel off the 2. We have okay, 2 over 4 divided by 6 over 4. And the 4 here can be cancelled off. We have a 2 over 6. Okay, so 2 over 6. In order to simplify this, I'm going to multiply numerator and denominator by the 6. I have a 12, all right, divided by 6. And the 12 can be written as a 2 of the 3. Okay, and divided by 6 by cancelling, simplify the 2 and the 6 here. Finally, I got my 3 over 3, which is equals to your right hand side. For this example, I'm going to start from the left hand side. Okay, we're trying to expand this, which is a tangent theta plus cotangent theta multiplied by tangent theta plus cotangent theta. Then we expand, we got the tangent square theta plus 2 of the tangent theta, cotangent theta, plus cotangent multiplied by cotangent, that will be cotangent square theta. And here we are going to make it all into this in terms of the secant square and the cosecant square, right? So the tangent square, I would like to convert it into the using the second identity, which is a tangent square theta plus 1 equals to secant square theta. Yeah. Okay. So I have a tangent square theta as a secant square theta minus 1. Okay, minus 1 plus the tangent theta. I'm trying to write it in the form of a sine over cos, and the cotangent is a cos over sine. Later on, when you cancel off, you will get 2 over here. And the cotangent square can be converted into, and using this identity, I change the cotangent square theta into the cosecant square theta minus 1. Okay, so let's see what happened. Secant sine Sine can be cancelled off, cos cancel off. Then I got my secant squared theta minus 1 plus 2 plus cosecant squared theta minus 1. Yeah. Okay. So finally, negative 1 plus 2 minus 1, that will be 0. And finally, we have a secant squared plus cosecant squared theta. Okay, this is equals to the right hand side. Then you say that you have proven the statement. Okay, thank you for watching.